Welcome to my presentation. A little about me, my name is Ryan. For about 10 years I've been trying to get people to call me Cold. It's not worked out very well. But whatever, we're going with that. I went to Colorado School of Mines. I have a degree in mathematics and computer science. I was hired out of school before I even graduated. My first job was at Lockheed Martin, Department of Defense Contracting. From there I moved on to like Tata, which is like an IBM, but they're mostly Indian company. Then Apple, Charter, Time Warner, DaVita, and many other startups and all that kind of things. So been around. I've been doing primarily mobile development since 2009. So with that in mind, the terms I'm going to use are kind of related to mobile, but it should be applicable to any technology. So. Yeah, hopefully you guys like the presentation. So has anybody seen this before? Nobody's seen this before?
Iron triangle.
Yeah, the software development triangle. So we call it like that because these types of diagrams, really the point of them is you can only choose two of the items. So that's why there's a hole in the center. By the way, I don't know if you guys can tell, my background is carbon fiber, so it's super aerodynamic. So there's a hole in the center of the triangle, and there's never a scenario in which all three of these qualities overlap, right? If it's fast and high quality, then it isn't low cost. If it's fast and low cost, then it isn't high quality. And if it has high quality and low cost, then it isn't fast. I just want you guys to keep thinking about this throughout the presentation, like how this, why we're doing these things. So when you go and implement a new feature, what do you do with your code? Anybody have any guesses? Just what do you do when you code? Well, you can only do two things, right? You can write code, or you can read code. Those are only two things you can actually do when you're changing code, right? Now, does anybody guess which one you do the most?
Read.
Yes, read. Oops. You definitely read code the most. Try it out sometime. If you don't believe me, go and record your session. Get on Twitch or something. Do whatever you need to do. Just watch a video of you coding one day. You're actually going to realize that what you're doing most of the time is just looking at code and trying to interpret it. And then once you interpret it, then you actually write lines of code for about 10% of the time. So with that in mind, what is the best way we improve our code?
Write better. Make it more readable.
Write better code, but how do we write better code?
Make it more readable.
So all we gotta do is make our code more readable. If reading code is the thing you do the most, then that's the simplest way to make things better, right? Just make it so everybody can interpret it faster, and then they develop faster. So maybe you're thinking something like, oh, my code is so readable, I'm the best ever. Well, you're perfect. I'll probably learn a lot from you too. But let me ask you a question. Oops. I don't think you guys can see this, but can anybody tell me what this does? I'm going to read it out to you real quick. So it's function get them, it returns an array of integers. The variable list1 equals array. And then for x in the list, if x subscript 0 equal 4, append it to the list, return the list. Anybody know what that function does? It gets them, right? That's exactly what it does. Here's the exact same code, but I would say more readable. So now it's get flag cells is the function name. It returns an array of cells. The variable we create is called flag cells. And then for each cell in the game board, we say if the cell status is flagged, then append it, then return those flag cells. Exact same code, right? It does the exact same thing to the computer. But to a human, it's completely different. So one of the key things of this, it has a descriptive function name. The array variable has a descriptive name. It's clear from the context and the for loop that you're checking the correct things, and it makes sense why you're matching those cells and why you're adding them to the array. So let's back up a little bit and really the question is, how do we solve problems as developers? Right? That's what we are. As engineers or software engineers or product managers, we still are all just solving problems. So what's our process for this, right? Quickly you start by identifying a problem. Then we research the problem and we generate a list of solutions. And then finally we evaluate those solutions. You're trying to find the one that works best. You might be constrained by your time, technology, or even an architecture. And then you just implement the solution. Right? This is an iterative process, so from the bottom you go back up to the top and you start doing the same things over and over. So how does this apply to development today? I'm sure a lot of people, especially juniors and seniors, will know this super through. What is our actual process that we do today, and how does it relate to that problem-solving process, right? So first you get a user story. Your product manager or whoever, they create some type of problem essentially. And then next you go and research. So we'll search the internet, we'll look for Stack Overflow blogs or any of those types of things. And you're going to find something that says, oh my god, I solved this the perfect way, just like this. And it's like, okay. Then we decide if it'll work. Again, we're constrained by time, technology, architectures. So what if this uses something that doesn't even apply to our project, or we use a different technology that we can't utilize? Suddenly we're in a spot where that's not a solution that we can utilize. And then after that, you just copy and paste it in your code base, and then you run it, and everything's good, right? It works. So this is all boiled down to a process we started called tutorial programming. The idea is you just find a tutorial, and that's you programming. But, Anybody see any problems with this? What's the problem with our software development triangle now?
Well, since you don't really fully understand the code that you may have copy and pasted, you just know it works.
Yeah, that's totally valid. You may not actually even understand the code. You may just paste it in and run and go, it works, so I'm good to go, right? But back to our software development triangle, right? It's fast and it's cheap, so therefore it can't have high quality. So now every part of our user story is actually interesting, right? Because there's implicit text on the user story that basically says, implement this story in our project. Nobody thinks about the in our project part. What that means is it has to conform to your architecture, it has to conform to your standards, it has to conform to your process, technologies, all those type of things. But there's no way any blog or tutorial actually knows what standards or architecture you have, right? It can't. It's literally so generalized that they have no idea what you're doing. But the valuable thing about tutorial programming is that the blogs and all those type of things, they're actually there to give you as much information and as fast as possible. And they take huge cuts, they cut corners just everywhere to give you that information. So they might be doing things like making web service calls and button action handlers. I don't know why you would do that, but so because these tutorials are essentially context-less, you're basically introducing the coding styles from whoever you've taken this information from, right? If they put the curly line on the next line of your if statement, you're taking their coding style. That's insane. I don't know why you do that either, but move on. So there's no sense of consistency. One tutorial might use if statements, while others use switches, and a third one might use flags and then do code forking. These are all the same way to do the same thing. They all work in the end. But simultaneously, if you just make these little changes across all your code base and there's completely inconsistent ways throughout your code base, it's going to be super messy. So coding this way really pushes you to keep code as consistent to the tutorial as possible. Since it's highly doubtful the tutorial will solve your exact problem, you just start adding things like to-do comments, like, I don't know, now save the user here, /to-do, save the user here, /to-do. Does anybody type /to-do fix anymore? You?
I've seen.
I've seen them. I don't believe in to-dos. I actually have, so something I'm going to talk about later is called a linter. It actually errors out if there's a to-do comment. So you can't actually build a project. If there's to-do, do. There's no to-do, it's do. Let's see. So all this stuff piles up and it causes your code to rot, right? Tutorial programming is like an infection. If you don't take care of it and it's spread throughout your code base, it's going to kill your project. It's just plain and simple. Alright, so maybe you're saying in your head, who would ever work like that? Who would ever just find a tutorial, copy paste it in, and push it to production? You know, surely I would never do something as reckless as just copy paste it like that. Well, I've done these things. I mean, I'm sure you guys have done these things. Am I ashamed that I have? A little bit. You know, but it's really easy to do. You know, how many of you have ever been in a situation where your product manager comes to you saying something like, we have a crash. We need a new version out tonight. Are you going to be able to make unit tests for this brand new architecture that you just created in 3 minutes? I'm not. I've been doing this for 10 years and I wouldn't be able to do that. So I guarantee that zero of us have only and will only ever work on completed brand new project or completely brand new projects that we wrote all the code for, right? So what if you take a position at a company, chances are you'll be working, you know, in an already established code base. Technically the project is brand new to you, right? But that doesn't mean that you don't have certain ways of doing things in the code, even if those are ways are subconscious. Again, you know, my favorite one, and I argue about this all the time, but it's curly line on the if statement. Curly bracket on the same line as an if statement. This is a law, no opinion based. You know, another good thing that I've actually seen in a lot of projects, like what if they use tabs instead of spaces for indentation? That sounds crazy, right? I completely agree. I would quit. I would quit if that was the first thing I saw. But let's say you got them to change and they started using spaces. By the way, they've done a study and people actually make more money if you use spaces and indentation. Something to think about. So when you're doing these things also, those sacrifices must be made, right? There's a big deadline coming up. You know, we need to get version 2.73 out the door next week. You know, well, you can't possibly get this feature without making some sacrifices. So what's the first thing that goes when you start to make sacrifices? Anybody have any guesses on that?
Let's go. Yes.
Tests. Unit tests, right? You know, we can add tests later. It's so simple. Just make your code testable as you're writing it, right? And then add the tests. Easy. Any company I've ever been at that done that, that has said that, they've never gone back and made a test. Just flat out, it never has happened. You know, so what goes on, what leaves after that? What do you get rid of after that? You know, soon there's going to be a conversation where you're in a room with a product manager and the rest of your team. This is the most important, confusing part. You're with the rest of your team. And he goes, we don't have time to make this feature in our architecture, so let's just do it the regular way. Is there any mobile developers in here? Oh, okay. MVC? Does that sound familiar? MVC? Yeah. So MVC, so in the mobile world, MVC, Model View Controller. We actually have like a better acronym for that. It's Massive View Controller. Basically, like our Model View Controller, you just put all the stuff in the view controller. And it works, right? Yeah, I mean, yeah, it works. So yeah, you say deuces to the architecture, right? You know, we can refactor later. You know, you just get this in right now, we'll refactor later. Again, you never go back and refactor. It never happens. I'm trying to think of like, does anybody have like any numbers as to like how many companies they've ever heard of them do any of these things? Mine's 100%. Literally every company I've ever been at has, in one way, said goodbye to unit test due to a deadline, or goodbye to architecture due to a deadline. All right, so let's say you're in this space. Probably all of you are. You know, what can we do to turn our code from raw into readable? You know, let's say there's different developers coming in. There's a high turn rate of developers right now. It's a really weird situation. There's strict deadlines. You know, quality's been sacrificed. But let's say that your team has actually come to a consensus and they said, okay, we need to make changes. Otherwise, it's not going to work, right? So there's really only two places to go from here, right? Somebody have guesses on those? There's two ways to change these things, right? You can throw away the entire application and start from scratch. I'm guessing everybody's thought of that at some point. You know, or we can continuously make it better over time. How many people came to develop Denver last year? Did you guys catch the talk on, it was something like when to throw things away or something like that? That was like the name of it. The consensus of it was, you know, there actually are times to completely re-architect an application. She did a pretty good job, I forgot what the speaker's name was. But basically there are times to completely re-architect. I'm kind of against that. due to cost reasons, but so have you ever just like, when you just get into a code base and you're just like, nope, this is not my thing, right? This is the whole like burn into the ground. You want a scorched earth policy, just get rid of everything and start over, right? This is a very costly mindset, right? Like it's not just money, it's actually time, right? If you're redesigning things, you're not growing as a person. So don't look at it from a cost perspective to the company, look at it from a cost perspective to you. You're not learning new technologies, you're not picking up ARKit and doing awesome like AR artwork things based upon the room. You're never growing like that. It's actually hurting you more than it's hurting the company. Also, the entire project is at a standstill in this position, right? Because you have to wait until every feature is re-implemented before you can make new features. You can't ever like create a re-architecture that loses features unless you know that they're not used. But analytics is another thing people tend to just ride right by. And if your entire team is rewriting the app, how does this actually affect your team, right? Like, developers are just rewriting code. That gets boring real quick. The app isn't getting fixed, no new features are being created, so the product team is pissed. The manager is pissed because they threw away all the money from the previous application. It's literally complete waste. And then now their roadmap is wrecked, so they have no idea when the new app's going to be out. And then people above the managers, so the CEOs, CTOs, they see nothing new being added. There's no new value being added. There's no new money being generated. This creates what I call trickle-down pressure. So we just went up the chain. Now, higher-ups put pressure on the managers then put pressure on product, and product puts pressure on developers. So what happens? Developers start making bad code by cutting corners, skipping unit tests, skipping architecture. Suddenly, you need to redesign the redesign. The exact same thing happens, and no one's learned from this very costly lesson, right? And after all this, are there actually any guarantees? Are you creating new features faster? Are you fixing bugs faster? Are your users happier? Look at this from a user's perspective. Nothing has actually changed in the application if you change all the code. Okay? So I'm definitely a fan of the continuously improvement path. It's a lot more simple in my opinion. The idea here is you keep working on your user stories, but as you touch any code, you leave it better. Okay? And then, so if you see something like the get them, just rename the function. Already just renaming the function is enough to like signify that this function does something better and you left the code better. The costs are integrated into the user stories. You're going to slow down in your velocity, but simultaneously the costs are like already integrated in there. It's not just like one giant cost to like make the entire application. Your velocity is going to slow down probably, but this is also you can have improved velocity in the future. As time goes on, areas of the app are been improved or easier to work for the developers, right? The product team is getting new features created, granted it's slower. Managers don't feel like they've thrown away all their money. Instead, they still have like they can just adjust their roadmap rather than throw away roadmaps. And higher ups actually see measurable progress. So this still creates a trickle-down pressure, but in a much more manageable state. And in this state, you're actually moving forward rather than like regressing, right? Or staying stagnant. But again, what are the guarantees here? In my opinion, when you're actually leaving the code better, then your quality is improving, which means it becomes easier to work on over time and reduce costs. I do want to say sometimes it's not just as simple as, let's continuously improve it. Sometimes you do have very coupled technologies. That's something you got to deal with. It's something you will deal with in your careers and all sorts of things. My biggest recommendation for that is get together with your team, architect things. Don't just assign one story to one user and tell them to go do things. It's never going to work out like that. Make sure to break down all these like big architecture decisions into manageable pieces, and think through all this stuff. Actually work based upon what you know in the past rather than guessing at what's going on in the future. Alright, so what are ways we improve, right? I mean, there's tons and tons and tons, right? So let's see. There's intention revealing names, avoid disinformation, meaningful distinctions, pronounceable names, searchable names, avoiding codings, avoid mental mapping, class names, method names. Don't be cute. Seriously, don't be cute. I hate that so much. Consistent concept words. The list goes on and on and on. You know, and on. I don't think anybody can read this. This presentation is pretty small. But like, I don't think anybody would agree that any of these things are insane, right? Like, you know, if your functions have side effects, has anybody been ever like amazed that that happened? It's always cool when you're coding it, right? But let's say you create a user and in fact it actually creates, it signs them up to an online dating site and gets 10 matches for them. That's pretty cool. You never know how you got 10 dating matches in your email box though, right? So, moving past all that stuff, by the way, there's books and books and books on it. One that I recommend the most is called Clean Code by Robert C. Martin. That's one of the best books I've ever read in my life. I don't like books. So let's talk about some things you can start doing today. You know, hopefully, you know, more senior people, more senior teams, they have these things already. But these should be like the bare minimum of things you need to have for your code bases, okay? So adopt some coding standards. You know, these are commonly referred to as like coding style guides. I'm sure a lot of you have them. But basically the idea behind these things is they make your code very similar. And the reason that's important is because it distributes domain knowledge. So again, let's go back to the idea of the readability of code. If my code looks exactly the same, just the look, the format of it, not exactly does the same thing or any of that type of stuff, but it looks the same, it's a lot easier for me to interpret because I'm used to that code base. You know, I did this at a company called Charter Communications. Charter Communications, huge cable company. They're like the Xfinity of the East. So what I did, so I came on there as a mobile development lead, and what I did was I researched a few styles. You know, I just like went around like Google, GitHub, those types of things, and I brought in all the things I liked and put them into a single Google document. Okay. And then I just sent that out to the entire team, and I said everybody has the chance to iterate on this, add their information, add notes, add anything they see valuable or don't see valuable, and then in that way, it creates a team building experience, so you actually start to relate to your fellow developers, right? Rather than being like confrontational about these things. You know, and if you don't want to like make one yourself, just steal someone's. It's so easy. Like Google has one, Apple has one, GitHub, Red Wenderlich, this seems stupid, but they have one. Just go and say, this is the style that we use. Find one that you mostly agree with. Find one that has, you know, the 8-space indentations. By the way, 8-space indentation is the way to go. So just find one that you mostly agree with and just say, this is what we use now. And furthermore, when they update it, yours is updated. You don't have to like change anything over time. One of the most important aspects of this type of thing is to use a linter. For Swift code, it's called, my favorite one's called Swiftling. And so what these types of things do is they'll add like warnings or errors to your code base when the style doesn't match up. So if there's a curly line in the next bracket, my code actually errors out. I can't build if that happens. After all that, standardize your architecture. MVC is not an architecture. If anybody tells you MVC is an architecture, they're lying to you. Punch them in the throat. You know, and here's the thing about this particular key point. I don't care what architecture you use. I want you to use a architecture. You know, your entire team should agree upon which one. The reason for these types of things are actually because of the transfer of domain knowledge. If you know exactly where some type of code is supposed to be, it's easy to find out how to change it, right? If you guys want to use KVO, which is a horrible idea, if you guys want to do that, but you know that everybody's using KVO, then it's really easy to actually make iterative changes over your code base and style. Finally, all code should be peer reviewed. I've found several companies that don't do this. They just merge into the master branch. Isn't it? Did you kind of get sick? I get sick. That doesn't. Anyway. Just merge directly into master branch. Literally no checks, none of that type of stuff. And I was just like, wow, that's crazy. So use pull requests, right? This is such an important part, you know. The peer review process is actually like a second stamp of approval. It's essentially saying, like, I think my code is good, I'm ready for you to tell me it's good. And if you don't tell me it's good, I need to make changes and make it better. You know, all the different subversion controls like GitHub, Bitbucket, they all have pull request functionality implemented in them. So just make use of that kind of stuff. To further, here's another big problem about peer reviews though. I've been at many companies where people, they don't peer review. They just say, they look at the diff in the pull request and they just go, yeah, that's good, it looks like it works. They didn't even actually run the code, right? So really all you need to do, to be a good peer reviewer, pull the branch, run it, make sure it works. Like, these aren't like insane things, right? Just make sure it works. If it works and you don't have code standards, which you totally should, make any changes or tell the original person about any changes you need to do. And if they don't do them, get them fired, I guess. I don't really know from that one. That's just ridiculous. But yeah, and if your code crashes based upon your changes, then you're wrong. You don't argue with me, the reviewer, about why you're wrong. These aren't in my notes anywhere, by the way. I've just kind of been going off with my bed. All right, so now we have a few ideas on how to improve. How do we convince our manager that we need to start doing these things? How do we convince our team? Let's assume for a second that not everyone is super logical, like all of us. So who do we even need to convince? You need to convince your manager, right? They're the one that pays your paychecks essentially. They have to be the sign off on like whether you do these like drastic changes. These new methods, they take time to get used to. Right? It's going to slow down your velocity. That's the concern with managers. So the thing you need to show to a manager is that these changes are actually going to make you better in the future. You can give links to case studies. You can show that unit testing is general practice. Conformed by the entire development community. These are the types of things where it's like really easy to just point them somewhere else if they don't believe you. Show them third-party implementations where there's tons of these things. You can totally just Google is unit testing valuable? You're gonna get to a don't Google that. You're gonna get to a Stack Overflow post that's like 50 billion views, and it's just one, and it's weird. The answers are commonly upvoted. One where it says no, and one where it says yes. Unit testing is super effective. Just please do it. Another thing, you shouldn't really need to be trying too hard to convince your manager, right? They trust you. They've hired you for this position. You're the expert. The reason they've given you this trust is because they need somebody else to do it, and then therefore must trust your expertise in this area. They're not going to fire you. This is the biggest thing they've ever seen. Like people if I tell them to take a unit test, they'll just find somebody else new to do the development. No, they won't do that. It's really, I don't know if has anybody been involved in interview processing? Like doing interviews with people and that sort of stuff? It's really hard to find good people, isn't it? Really hard. I used to digress to the questions like, what's an array? And I would get people like, I don't know what that is, I don't really use those. And I go, you don't really use arrays? I was just always so flabbergasted by that. How do you not use that? Again, the easiest thing I've found to do to convince managers, show them third-party things. All these things that I've mentioned are really standard programming practices, right? So, unit testing, peer review, and architecture, those are all standard. It's not difficult to just find third-party things that reinforce these ideas. A lot of companies get very concerned over budgets and timelines and start taking those shortcuts. But these shortcuts actually hurt your code base on the long run, right? Taking shortcuts now actually just pushes your technical debt to the future. And then you're in a spot where it costs a lot more money to actually do these types of things, right? So start talking in terms of dollars instead of quality to your life, and other people will start to understand. All right, so let's say you get past your manager, who else do you need to convince? One of the hardest things I've ever done is convince an iOS developer to not use MVC. It's insane. It's super easy for someone, like an iOS developer, to just be like, I know MVC. Apple's way of standard architecture is MVC. Let's just keep using MVC. One of the biggest things that I've done in this area is actually tell somebody to do a user story that I just did. I say, revert back to this branch, and I want you to do the same user story. You don't know about this area of code that I was just in, right? I can do this code now in 5 minutes. It took me 3 days to find the KVO thing that's in a different singleton class on the other side of the project that has nothing to do related to this. But I figured out how to do it. Now I want you to do that thing. And typically that's the type of time when people go, oh wait, yeah, this isn't working out, right? Okay, so with all that said, is there a place for tutorial programming? Of course, they're great learning tools, right? They're designed to give you as much information in as little time as possible. And they take huge shortcuts, like making web service calls and button action handlers. There's some ways we can tweak tutorial programming to make them more effective, right? You need to evaluate a solution and adopt it. Don't take it. It's not a copy-paste. You can copy-paste some of the stuff if you, blah, 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 don't want to type it out. But really, you take the implementation and you adopt it. You start adding more clear function names, more clear variables. By the way, I don't believe in comments. Does anybody believe in comments? Okay. Do you have a good reason?
Even if you're very clear, sometimes you might have that extra context that you can't get with the name.
Perfect. This is the only time I believe in comments. Your code should be expressive of your functionality, right? No longer are we in this spot 30 years ago where our programs can be larger than a kilobyte, right? Now we're in a spot where we have a tab completion. It doesn't matter how long your variable name is now, so it needs to be expressive. If you are unable to express yourself through your code, then you need to comment. But in most cases, 99%, you should be able to express yourself through the code. It should be flagged cells. Literally, it's the flagged cells. I don't know how else to explain that, right? That's the perfect way to be expressing your code. It's just naming things better. All right, and then anything you take, keep the same mindset of making it better, right? Make sure you always improve the code that you implement, regardless if it was yours, somebody else's, or somebody brand new's, some blog guys. If they don't have clear function names, make them clear. If they don't have clear variable names, make them clear. You need to convey what they're used for, and then change them so that they do use those things, right? By the way, go back to comments. Comments are documentation, right? Has anybody ever seen a comment that didn't actually apply to the code that it was on? Anybody see the comment that was wrong about the code that it was about? So actually in that situation, right, you have to update your code in 2 places. You have to update the comment and the code. And then if you don't update the comment, you've actually created disinformation, right? It's like somebody's come in and sabotaged a project, but it was you. Alright, so with all that information that I've kind of spit out here, this is just really been a big giant rant. Please do better stuff. I personally recommend a Viper architecture. So this is a solid design principle architecture. It has 6 layers. Each layer has a single responsibility, and all the layer interfaces are abstracted into protocols. So in Java, that'd be interfaces, and C# that'd be interfaces. I don't know. I can't really C#. I try to make Viper very simple, and I can in a few short sentences. All right. So there's a wireframe. It's responsible for instantiation and navigation. There's a presenter. It's responsible for business logic. There's an interactor. It's responsible for data logic. And then finally, there's a view layer that's responsible for the user interface. In 4 sentences, I can describe. Now, any one of you, with just those 4 sentences, should be able to come into one of my projects and determine where to make a change in the code. I was supposed to click here, my bad. The main goals of Viper are really to be, iteration. They're designed to make it really easy to change things over time. Because now if we go to back to an MVC architecture, if you need to replace a view, you actually have to rewrite the whole thing. You have to find all the web service calls, you put in the new button action handlers because you're doing things bad. And then you keep remaking these things over and over that shouldn't need to be remade. By comparison to a Viper architecture, all I need to do is replace my view layer to change the user interface completely. To make new web service calls, all I gotta do is change the interactor to use these new web service calls. If I don't want this to connect using Alamo Fire versus RESTKit anymore, I only have to change one place versus changing hundreds and hundreds and hundreds of different view controllers. Another big point of this is collaboration. If you're working on a single view controller with an entire team, you're going to have merge conflicts. That's not something I ever discussed. Make sure to use subversioning controls, GitHub. If you don't do that, you're, I don't, yeah, move on. The other thing about Viper is things are reusable. So services are abstracted such that, so let's say this is a get user service. I can now use that get user service anywhere in my application by comparison to re-implementing the Alamo Fire call or RESTKit call or something like that. You know, it essentially creates modularity. So one of these things that I really love that I've made is called a selection list. Everybody uses a selection list, right? There's tons of them where it's like, 10 strings or something like that, select one of the strings. I now actually have a module, so I can create a full selection list and put it on any view controller, 2 minutes. And it's all because of this modularity, right? Things are reusable in this situation. And finally, it makes them testable. One of the biggest things that I've heard the most about people who hate unit testing is it's actually really hard to unit test code that's just organized poorly. It's really hard to, if things aren't abstracted, there's no dependency injection, those types of stuff. It's really hard to make sure these things all work correctly. And that's why testing is hard, and that's why testing actually creates this huge barrier for new programmers who come into the field. Okay? Because all these things are abstracted behind interfaces, it's easy to dependency inject them with a new mock class that just conforms to the same interface. And then all you have to do is just say that the correct call is being made, and then you're done, right? That's all you need to do from a testing standpoint. Okay. So to put this in perspective, I've been working with a Viper architecture for 3 years. I did it at DeVita, where they have a Falcon Rounding app, it's a kidney dialysis app for kidney doctors. They go to dialysis centers and they need to walk around all their patients while they're getting their blood cleaned, right? So with the application, you click on the patient name, brings up all their medical history, all that type of stuff. You start asking any questions, if you see any irregularities, all that type of stuff. And then you move on. What they were doing before. All their web services would get dictionaries, and then they would pass around the dictionaries. They never even abstracted them into objects to use throughout the project. So everywhere you had to check to make sure that the values weren't nil, and all that type of stuff. Like when you're pulling a value out of a dictionary, it was pretty crazy. Next we use this at a company called Maestro. It's a trip itinerary planner. So you want to go to Japan. It goes, all right, well, let's search Google for some places you want to check out. Say, okay, add those, and boom, they're already in there. Now when you go to Japan, you have all this trip itinerary right in your phone. You can go to everywhere, get directions, call the place, make notes, all that type of stuff. Next, I did a company called Fubo TV, which is a client consumption application for live sports. Now these 3 applications, completely different industries, right? But I'm able to use the same architecture for all of them. Anyways, so those type of things, and by the way, bring those architectures into a company, it completely transforms a company, right? It makes it so easy to now you're suddenly using unit tests. Now you're suddenly able to implement new features. Now you're able to reuse things and your velocity shoots up. It's actually really cool when you start to this has actually been one of the most fun things I've ever done in my career, is to go into companies that have just shambles of architecture, or shambles of code, and then turn them into something great that everybody likes to work. Has anybody else ever done this where you wake up in the morning and you go, why do I go to this job anymore? I've done it. I've done it plenty of times, right? And that's all because the code is actually running, right? It's you don't want to work in that code base anymore, so why do you even try anymore? All right, anyway, so are there ever times to not do some of these things? They all sound like great things, right? So are there ever times to not just, no? Yeah, there are. Yeah. Maybe you're exploring a new technology, right? Maybe you're actually trying to use a new type of database system or something like that. You're not going to write unit testing for things that you're not going to use anymore, right? You don't need to, when you're doing these types of explorations, they don't need to perfectly conform your architecture. They don't need unit tests. In iOS we have this thing called Playgrounds. I don't know if they have these in other languages or anything like that. But Playground is just kind of I don't know, just a big open file, and you just do stuff in it, and it's always compiling. Pretty cool thing. You can also just create a test branch off your main branch and just do that type of exploration, by the way. But the main point about exploration code is that you throw it away, okay? You throw away this code. You don't use it. You don't take it into your production application. Implement it when you're exploring, implement it your first time, and then create a new branch and implement it correctly. Another big thing about this throwaway, if you're actually making a feature that you know is like a stepping stone to a new feature or something like that in the future, that's throwaway code. Just as long as you know you're going to throw it away, you don't need to do these things because they take time and money. That's really the main reason. The other big thing is a super hard deadline. So I mean, with all this stuff that I've said so far, it's like deadlines are a real thing. Deadlines are something that you're always going to hit. Someone above you is going to say that there's a deadline. They're probably lying to you, by the way. But if you have a super deadline, like tomorrow, again, we need a fix for this crash out tonight, then yeah, you don't have time to do this. But you have to understand it and make it clear to the people above you that you're actually eating technical debt. You're going to have to do this at some point in the future. You're going to have to refactor, you're going to have to make it better, or it's going to hurt you. By the way, one of my favorite deadlines, I know the date, it was August 17th. I don't even know what we're doing in the release, but we kept getting communicated down. August 17th, we gotta be done on August 17th. We gotta get done on August 17th. So okay, we're trying. More and more clear that we weren't gonna make that. Finally, I was in a CTO level discussion. This is actually at Charter Communications. I'm sorry, an SVP level discussion. The head of the entire program was asking me, why are we not gonna make it? To which I responded was, you didn't give us enough time. We tried really hard, but why is this a deadline? Because it instantly became clear to me, I didn't know why this was a deadline. The CEO of the company's favorite show was premiering August 17th. They wanted the brand new version of the application just so the CEO could watch the new version of the application for his premiere of his show. I just thought that was a really cool deadline. I don't really got many stories up there. I know it's pretty awesome. All right, so in conclusion, right? It's actually really easy to make better code, right? We just need to make it easier to read, and then everything else improves. Just improve the quality of code, adopt all the things that I've mentioned here, and you're just going to see gradual improvement. Again, if our code is better, it's easier to change, and it makes our development faster, and thus lowers costs. I want to thank you all for being here, and I hope we work together in the future, but in preparation that day, please make better code. Something I want to share with you guys are some of the tools that I actually use. I use these on a daily basis. One of them is a default pull request template. Okay. So what it does is, you can't really see it. Okay. What it does is you can actually just import this file into your subversioning control, and anytime you open up a pull request, this template will show up. And so this one says story link, so you just put a link to the story so anybody who's reviewing can go to the story, figure out the things. And then it's a checklist. And this is the retardedly stupid checklist. It's like, read the story. Mark a checkbox next to read the story. Like, right? The other things are like, will it merge into the correct branch? Pull the branch. Does the app run? Does it have 0 warnings? Run the unit test. Do the unit tests pass? Go through the changes. Do they check for nils and nulls? Do they count for potential crashes? Are they clean? Are they easily readable? These are these types of things where it should be subconscious, but if you have a checklist that just says, yes, I've checked for that, it makes you remember that you need to do those things, and then you actually perform them. Okay. Oh, by the way, this actually creates a checklist inside the pull request, so the pull reviewer can actually just click and check off these things. It's a really, really cool thing. This is what it turned out to look like. Alright, so with that, if you have any questions, again, you can download these tools at tools.coletesco.com. My email and my Twitter handle. I don't really go on Twitter, but I guess that's a thing. So yeah, any questions?